Okay, so welcome to the first lecture of Chemistry 110. All right, so let's get into it. What is chemistry? Okay, there's a lot of different definitions out there, but I'm just going to give you one right now, and you will see a couple as we go along, other one. But basically, chemistry is a study of matter and the study of the changes in matter. All right, so that's a good place to start, but it kind of leaves us is the thing is what is matter? Okay, so matter is just about everything around us that we can touch, feel, hear, smell. Okay, even not see. It's stuff. All right, there are basically three different things in the universe. There's matter, there's space, and there's energy. Okay, that's it. Matter has two main things that give it makes it matter. It takes up space. That is, it has volume, which is length, width, and height. Okay, so if you go grab something, grab your cell phone, you'll see that it's three dimensional, and it takes up space. The other characteristic it has is it has inertia, and inertia is the quality of a substance not to move. So all matter has an inherent ability not to move. That's a pretty important thing right there. Okay, so if you know, pick up if you look at your phone, it's not moving, and what you have to do to get it moving is you have to push it. So a quantity, so this quality has a quantitative measure, and we call that mass. The more inertia something has, the harder it is to get it moving, the more mass it has. So matter has mass and it has volume. Now, on a test, if I ask you what are two characteristics, I might say and explain. Just don't write down volume and inertia or mass. Okay, explain it a little bit. Say, explain that volume is length, width, and height, and inertia is the inability for of substance to move. Now, one of the things that's related to mass but is not mass is weight. Okay, so so we tend to your cell phone weighs a certain amount. Okay, um, you can put it on a scale and weigh it. You can take your pencil and put it on the scale and weigh it. Okay, but the thing is that weight is not mass because weight includes how gravity affects the mass. So if you took uh, your cell phone to the moon and you put it on the scale on the moon, it would weigh less. All right, but nothing inherently about the cell phone would have changed. It still has the same mass, but it weighs differently. So weight will relate to gravity. Now in this class, I'll often use the word weight and mass interchangeably. But really, when we talk about um, a substance inertia, it should be classified as mass. So if I say go weigh 2 grams of this substance, I'm really saying mass 2 grams of that substance. All right. So mass is inherent; it doesn't change, while weight can change depending on gravity. And here's an example of it in terms of me. All right. So and then we have, like I said, matter has volume, and that's a fairly simple concept. It's length, width, and depth. The volume of object is same everywhere. So unless we get into special relativity, but we're not. Okay. So if you take your cell phone and you move it anywhere in the universe, it's going to have the same volume. The way we measure volume can be feet squared cubed, centimeters cubed, etc. We'll go over several different of the units that we can use for volume, like liters and milliliters as well. I'll have a separate PowerPoint to go over units. A common mistake people make is talk about area, how it relates to volume. And in some ways they're very related. Area is just two dimensions like length times width, while volume is all three. So we're going to be dealing with volume, not area usually. But when we do, we might be dealing with area, but that's not a quality of matter. So matter's qualities are a volume and mass. Okay, so classification of matter. All right, before we get started with this, let me give you a little heads up on how you may want to approach going through this PowerPoint. There are approximately 45 slides, and you can actually kind of break this up into about 3 different sections. Right now, we are talking about matter. Just got done talking about 2 qualities of matter. Now we're going to talk about classification matters. We're going to go over this table, the classification matter, and then and that'll be in the main part for now, and then the last part would be talk about our compounds, and this is going to be quite intense here. So I'll let you know when you sort of may want to take a break from this, and so that you can be ready to take on compounds in a more and really be able to concentrate on it. So let's get into matter. So if you do have some matter, what you want to do is decide what you can do with it. All right. So there are 2 different kinds of matter. We can classify matter as mixtures or pure substances. And what we're going to do is I'll just briefly go through each one of these, show you how the table is set up, and then we're going to go through mixtures and pure substances. So you have mixtures, and mixtures can be broken up into heterogeneous and homogeneous, and we'll talk about that in a minute. And pure substances can be broken down into compounds and elements. All right. Mixtures. A heterogeneous mixture can be broken down into homogeneous mixtures, and homogeneous mixtures can be broken down into compounds and elements. So if you have a mixture, you can just break it apart and keep on breaking it apart until you get down to compounds and elements. If you have a compound, and we'll talk about that, compounds are atoms that are chemically combined. They can be broken down into their elements, and then the elements can be broken down into subatomic particles. So we have mixtures going this way, and then we have pure substances. So this is actually sort of split in 2. You have your mixtures and pure substances, and they're 2 completely different. All right, mixtures. Okay, a mixture is from the previous slide. You will see that a mixture is does not have a definite composition. That means you can never make it the same. For instance, your grandma's lemonade, she tells you to make her special lemonade, what you need to do is take 3 lemons and a gallon of water. All right. Well, and she may say that the lemon's got to fit into the palm of your hand or something like that. Okay. You can never make her lemonade exactly the same every time, because the lemons are never the same. All right. Coca-Cola. Coca-Cola is a mixture. No matter how hard they try, and it seems like they make it the same all the time, they can't make it exactly the same. anytime you have to measure out quantities and mix them, you will get you'll never be exactly precise in making something. So, and also mixtures can only be made by mixing. So when you take a mixture, you mix things together. And when you mix them together, you really don't change what's in them. Okay. Now, pure substances are the opposite. When you make a pure substance like water, you can't mess that up. It's always going to be 2 hydrogens and 1 oxygen. And the only way you can make those water is chemistry. All right, so back to mixtures. There are 2 kinds of mixtures, homogeneous and hetero. Homo means same throughout, and hetero means different throughout, okay? So homogeneous, you're going to see, is like Coca-Cola. It looks like it's the same substance all the way through. It's this brown color all the way through. You can't see any separation between whatever it's made out of. A heterogeneous mixture is like sand and water. You can see the sand and you can see the water. So heterogeneous is the simplest and easy to see that it's a mixture. You will see a definite separation between the substances, like oil and water or sand and water. You can see the sand, you can see the water. Homogeneous mixtures are harder to recognize. When you look at them, they appear to be only one thing. They have a uniform composition, like salt water or Coca-Cola, all right? Or the paint on your wall, okay? That's all one color. These usually require, it's hard to tell, and these are harder to separate or break apart than the heterogeneous. Heterogeneous, you just can sort of separate them through maybe filtering. Okay, one of the properties of mixture is that it's not dependent on how much of any things that make it up. When you make salt water, it will be salt water with 1 gram of salt or a pound of salt. Okay, it's still going to be salt water. There's no definite composition to it. It'll always you can make them different. And you can never make them exactly the same. Pure mixtures, eventually you can break them down into pure substances, and the only way you can break or separate the component parts of a mixture is by physical separation. So you make and break mixtures using physical methods. Okay, and we'll go over some of those. All right, pure substances. Unlike mixture, pure substances have definite composition. That is, water is always H2O. It's 2 hydrogens and 1 oxygen. Okay, this is one way you can tell if you have a pure substance, is that you always make it the same. In fact, this is a law, the law of definite composition. Pure substances have an exact amount and kind of element that make them up, while mixtures do not. They are always made the same. So pure substances follow the law of definite compositions. Pure substances, you cannot separate them by physical means. So you can't filter. If you can't take the hydrogen and oxygen and hammer them apart. You can't filter the hydrogen from the oxygen. Okay, you can't boil the hydrogen from the oxygen. So there's a whole battery of physical tests, and all these tests, and none of those will break apart the water. Okay, but the way that you can separate the water into its components is through chemistry. So, and the way that you make water is through chemistry. So another definition of chemistry is what is needed to make or break pure substances. All right, now let's talk about the physical separations. So I said you can't separate the hydrogen and oxygen uh, by physical separation. So what are physical separations? So there's a whole bunch of different ways of physically separating. So let's say you have some Coca-Cola, and what you want to do is separate the parts. Okay, since Coca-Cola is a mixture, what you can do is use one of these methods to separate all the things that make up Coca-Cola. So if you look on the side of a can, you'll see that it says Coca-Cola has sugar in it, it has water, it has phosphoric acid or whatever. So let's say we want to separate the sugar from the water. The way that I would do that is I would boil the water or evaporate the water off. Okay, and what would be left is the sugar. Okay, and then we have these other methods as well. So also when you get done separating is that you'll end up having the substance exactly as it was when you started. So when you put sugar into, or salt into water, the salt is salt. It doesn't change who it is. It's still salt. Okay, when you put sugar into water, it doesn't change the sugar. The sugar is still sugar. So when you make a mixture, the things that make it up are still there. They haven't changed. You're just adding them together. On the other hand, pure substances, their components, will undergo changes. So oxygen, when you take oxygen and hydrogen and look at them, and individually, oxygen has certain properties, and it behaves certain ways, and hydrogen has some properties and it behaves in certain ways. And then you mix them together, make water. That new substance doesn't have the same properties as the hydrogen and the oxygen that you started with. Now, if you put sugar into water, it's still sweet. It's just like the sugar that you have. But when you put oxygen into water, it no longer behaves like oxygen. It's a whole new thing. It's water. So chemistry produces new things, okay? So mixtures, you're not really making a new thing. You're getting, you're mixing different things to come up with a new thing that has all these different flavors. Same flavors you can distinguish. But in chemistry, when you mix things together, you really can't tell where the things that made it up came from. Okay, so one of the things is that we look at with mixtures and pure substances is we look at their chemical and physical properties. And both mixtures will have physical properties, and chemical or pure substance will have both. So a physical property is things that you notice about a substance, what it looks like, what it smells like, what it feels like, what the boiling point is, and what's its density. Things that you can measure without doing anything to it. Okay, just by looking at it, by putting it on a scale, weighing it, and so forth. There are intrinsic physical properties that are independent of the mass of the substance, and these are the boiling point density. So it doesn't matter how. If you have a gallon of water and a cup of water, they're both going to boil at the same temperature. Density, I'm not sure if you know what density is, but we'll talk about that more in the first lab. is it's a relationship between mass and volume. So if you have, no matter what, the density of water is 1 gram per mil. So if you have 10 grams of water, it will take up a space of 10 mils. And you don't have to know this right here, but there's properties that are involved in mass of substance as well. But physical properties are things that you can notice about the substance without doing anything to it. Okay, chemical property is a little bit more difficult to define. It's a property when a substance undergoes chemical change. So it has to be a pure substance. So chemical properties only apply to pure substances because these are things that undergo chemical changes. For instance, when oxygen mixes with paper in the presence of heat, carbon dioxide and water are given off. So this is a chemical property of oxygen. That is, when it combines with paper, it forms carbon dioxide and water. So that's the kind of thing. You see, really, what you have to do is you have to do chemistry to figure out the chemical properties. You just can't look at a pure substance and know its chemical properties. You might be able to guess, but you have to do the chemistry to really figure out what its chemical properties are. Chemical properties are dependent on what happens in a chemical change. Right. Physical properties are only dependent on how the substance looks, weighs, and so forth. Okay, so one of the things about mixtures and pure substances, it's kind of easy to get mixed up, is homogeneous mixtures. Homogeneous mixtures are interesting. They technically are not pure substance, but when we look at homogeneous mixtures, they look an awful lot like pure substance in how they behave and look. So if you take some Coca-Cola, it looks like it could be a pure substance. You can't see, it looks like it may be just all one thing. All right. So, or salt water. It's a homogeneous mixture. We can't tell where the salt ends and the water begins. So it looks like it could just be all one pure thing. It could be just a pure substance. All right, and the reason why this is why it looks this way is because the salt is evenly distributed through the water. So how would you, let's say I give you a substance and I say, is this a homogeneous mixture or a pure substance? So let's say I give you a green liquid that's clear all the way through, and I go, is this a pure substance or a homogeneous mixture? Okay, so first thing you're going to do is assume that it's a mixture. And what you will do is you go to that list of physical separation techniques and run the green liquid through that. You'll boil it, filter it, do all those different things. Okay. Now, as you do those things, you may and probably will be able to separate it into different parts. And therefore you know that it's a homogeneous mixtures. Okay. But if you go through all of that, all those different separation techniques, and you're still not able to get anything, it's still the green liquid, then you're pretty sure you have a pure substance. Okay. So homogeneous mixtures and pure substances look a lot alike. They look like they have uniform composition. Okay, they look like they could all just be one thing. But the way to tell is to have that substance undergo physical separations. And you may be able to break it. And when you do, if you do, it's a mixture. If you can't, then you're pretty sure you have a pure substance. In fact, that's how scientists find pure substances. They'll take something and they'll have it undergo all these separation techniques, and if they can't break it down by any of the separation techniques, they're pretty sure they have a new substance. Okay, so this class is chemistry, and I just told you another definition of chemistry is what is needed to make or break pure substances. So this is chemistry, so that means we're going to deal with pure substances. So let's look at some basic kind of definitions that we use in our class. Now, at the end of this PowerPoint, you're going to have a list of there will be a list of definitions that you're going to have to know for test at some point. Okay, I will have a Quizlet available to you where you can use flashcards to help you with that. So I will add on to this PowerPoint the list of the definitions that you will have to know and the Quizlet link. Okay, so here's some basic definitions. So we have matter. What is matter? And then we have volume and mass. And then we have the different kinds of matter. We have mixtures and pure substances, and then mixtures can be heterogeneous or homogeneous. So there's another set of definitions. And now we're going to get into pure substances and some more definitions. So a couple words you're going to hear a lot for the rest of this class are atoms and molecules. All right. Atoms are the individual basic entity of an element that has the same chemical properties as the element. So an atom is the smallest piece of an element. Okay. Now elements have unique chemical properties and physical properties. And we'll get into those in a little bit. Atoms are made out of protons, neutrons, and electrons. And all of this will be more specified as we go along. Okay, molecules. Molecules are combinations of atoms chemically bonded in a definite ratio. So you have to know both of these definitions here. All right, so what does this mean? Combination of atoms. So it's going to be two or more atoms, chemically bonded, okay, in a definite ratio. So that means water is a molecule because it has two or more atoms, and it's chemically bonded, and it has always the same composition, 2 H's and 1 O. Molecules can either be made out of the same atom type or element, and these are called elemental molecules, like O2, N2, H2. And they can be made out of different elements, like sodium chloride and water, and these are called compounds. And we'll be getting into these. So what we can do, and we're going to see this in a minute, is that physical substances can be broken down into elements and then into compounds. All right, law of multiple portions and allotropes. A property of pure substances is that atoms can bond to form in different proportions. And process change the chemical and physical properties of the substance. For instance, hydrogen and oxygen can form water, and they also can form hydrogen peroxide. There's these things called allotropes, and allotrope is elements can be, and this is just elements, so allotropes relate to elements, is element can have different molecular structures. It can have S2 or S8 for sulfur, carbons, and so forth. So So this is a molecule of sulfur, and this is another molecule of sulfur. So these are elemental molecules. Okay, these are compounds. So allotropes only are related only to elemental molecules.